Hello and welcome to another video here at Pragmatic Works. My name is Mitchell Pearson and today we have another DAX video for you. In fact, today we're going to be taking a look at the AVERAGEX function. We're going to talk a little bit about fact tables and granularity, and we're also going to revisit this concept that we've talked about in the past before, which is using a virtual table or a function that returns a table in order to kind of manipulate the data and get it the way that we need so we can get the results that we want. So this is going to be us diving in and just kind of talking about a scenario, understanding the data that we're working with, and then creating the end result with an X function. This is going to be great. So the first thing I want to do is I want to jump right into Power BI Desktop, and I want to talk about the scenario and just kind of get it started here. So the first thing I have is a very basic report. You've probably seen this report many times before, kind of stick with the same data here. And what I want to accomplish is we have this goal that we want to return the total sales or even the average sales for large orders, transactions that were of above a certain amount, right? So for example, maybe we want to return the total sales for all transactions where the total sales for that transaction was greater than $3,000 or $3,500 or whatever it might be for our scenario for this situation. So if we go over here and we look at the data in the table view, and I believe I've already sorted it, I have, you'll see right here that we have our sales amount. And so we have a bunch of rows that are above 3,500, 3,000. And if I click on it, you'll see that we have a bunch of rows that are not necessarily above 3,000. So we have a bunch of rows that are below 3,000 and a bunch of rows that are above 3,000. So let's quickly solve kind of answer the question that we were asked, that we were tasked to complete very quickly here. So I've been asked to come in here and create a new measure that's going to return the total sales for all transactions that are greater than, let's go with $3,000. So the first thing I'll do is come over here, right click on Internet Sales and create a new measure. All right, and so we will call this measure total sales, and I'll even just do this to keep it very simple. Maybe call it large orders, whatever works for you. And then I'll come down here. And I know what I want to do is I want to get the total sales, but only for the rows where the sales amount was greater than 3,000, right? So in practicality, this can actually be a very easy, very simple calculation. This is going to be wrong, so stick with me, all right? Calculate. And then I'm going to do, I'll hit escape to get rid of the tooltip there. And then I'm going to do total sales. And then on the next line, I'm going to put in our filter, right? And my filter is going to be very simple. Filter down the result set to where the sales amount in the internet sales table is greater than 3,000. So very simple, very basic. And in a lot of situations, this would be correct. That's why we're going to have a conversation in just a moment about the granularity of your fact table and why that's important. So I'm going to hit enter here. That's going to pop up right there. We'll even take a moment to format this. And then I'm going to go ahead and add that new measure into our table. And you'll notice that there is a difference between total sales and total sales greater than 3,000, which tells me that my total sales greater than 3,000 is not summing up the sales amount for every transaction. In fact, I think when you get to later years in this data set, there's a bigger disparity. Actually, it gets to blank because they're later in the data. We're not selling those big products anymore, what have you. But this is technically doing what we told it to do. All right, it is technically doing what we told it to do. So let's look at it one more time. So this is going to, the total sales measure in this context is just sum the sales amount from the internet sales table within the filter context, within whatever filters are being applied. That's what total sales is doing. The filter that we're adding with calculate is we're saying, hey, only sum up the internet sales amount where the rows in the internet sales table has a sales amount greater than 3,000. Now we still have these other filters. There's still a filter on the year, the quarter, and the month. So those are filtering down the sales table. But now we're adding to that filter and saying, all right, but only if the rows that are for that month, that quarter, that year, above this amount. And again, in many scenarios, this is right. However, in our scenario, this is not correct. And I've actually seen this in practice before where somebody did this and they realized later it was not right. And so I'm going to show you how to solve it. And the reason it's not right is because of the granularity of our fact table. Now, what does granularity of our fact table mean? That's a very fancy word that simply means what is the grain statement of your fact statement? Or in other words, what does one row in your fact table represent? And see, there lies really the problem for us. One row in my fact table does not represent a transaction. One row in my fact table represents a line item on a transaction. You see the problem? So when I'm filtering down this table where internet sales amount is greater than 3,000, I'm filtering it down to say only include the records where the line item is greater than 3,000. So we're not actually including everything here. And that's very important to understand. If we were to come over to the sales order number and sort this in ascending order, eventually we're going to see that we have some sales order numbers that have duplicate rows. And the reason they have duplicate rows is because they have multiple line items. It's like if we go to the grocery store and in that transaction, you buy 10 different items. And I thought I saw one right in here. All right, I didn't quite plan this part out, but I wanted to show it very briefly. You know what an easier way to do this would be? Let's grab something that is in the 2 range here, and then let's see, we'll go with 51176. So I'm going to clear this filter. I just want to show you this. We'll go with SO51106, right? Was it 1106 or 76? I think it was 76. All right, let's try that one. There we go. So we have a sales order number right here that has multiple line items. So if I want to know the total for the sales order number for the transaction, I have to add up all the line items first before I filter the table. And so understanding the grain statement of the table is very important. Now, this is a good grain statement. When you build a fact table, and this is something I did for years and years before I moved into training, and I still help customers build their data warehouses today. When you build a fact table, you really want to design it at the lowest level of what we call granularity. And that way you can always roll up and aggregate up to whatever level you want. But if you create this at a higher level and then somebody says, oh, I want to go down and look at the line item, you're like, oh, you can't because I didn't bring that data in. Now you have a problem. So this is a good fact table. This is good. So there's a couple ways to approach this now. Let's think about this. We understand the situation. I need to find out what is the total sales amount for that sales order number. And if that total for that sales order number is greater than 3,000, then include it inside the final calculation. Else we do not, right? We would exclude it. A couple ways to handle this. One is you could create another physical table in the model. You could create an aggregated fact table. That is a thing that you could potentially do. I've worked for customers where one customer I worked for probably about 7-8 years ago, they had 400 million rows of data in one data source, and they had about 20, and they were all large, 400 million rows of data per day. That's a large data model. Yes, we created aggregated fact tables for them. Yes, we built multidimensional cubes. This is not 400 million rows. So do I need to add complexity to my data model by adding a physical table for one calculation that I want to do? Probably not. Probably not what I want to do here. What we could do though, and you've heard me talk about this a lot in the past, is build some kind of virtual table. Now, if you come from a SQL background like I do, it's very common for us to build a common table expression or a temporary table or a view or a subquery or what have you that first kind of takes the data, does that aggregation that we need to do, and then once the data is aggregated, then we can perform whatever the operations we need to perform on it, right? So that's what we're going to do. So without anything else here, let's go back over to the report view. Now, if you want to write this, there's going to be a multiple kind of different ways you can write this expression, but I'm going to open that back up. And what I want to do here is I really want to, I'll just comment this out for a minute in case I want to come back. I want to start building a virtualized table. And the first thing I need to do is I need to group by the transaction number and get the sales amount for each transaction number, right? So I'm going to do a summarize here. And I am going to summarize the internet sales table. And I'm going to return from the internet sales table here the sales order number, each individual transaction, right? So we're going to do internet sales order. By the way, if you're zoomed in like I am, where you hold down control and use your mouse wheel, you can always scroll over. And I want to get the order number, not the line number. And that's the first thing I want to do. Now, the next thing I want to do is I want to filter down this table and say only return the rows from this table where the sales order number is greater than 3,000. Now I could technically add a column to this virtual table. I could say add columns. I could add a new column called total sales. I could do that, but I don't need to here. What I can just do is I can say, all right, I want to do SUMX over this table. And down here, and I'll talk exactly about what this does in just a moment. Actually, let's filter first. I should filter first. I'm going to filter first, so I forgot about that step for a moment there. I'm going to format this, slide that in, and of course the filter we want to apply is what? It is, I'm just going to use the measure that we already have here called total sales, where the total sales is greater than 3,000, right? So filter down, it's going to give me a list of every distinct sales order number. That's what this does. So when we were looking at a moment ago, 50, whatever it was, S05 something, something, something. When we were looking at that one transaction number, sales order number, it had 2 line items, so it had 2 records. This summarized, because of the way we built it, is only going to have that line item or that sales transaction number once, and the total sales is going to sum up the sales for that sales order number exactly the way that we want it to, okay? And then we're going to say, hey, if it's greater than 3,000, keep it. That's good. So this right here is going to return all of my sales order numbers that are greater than 3,000. Now, that gives me the filtered table that I wanted. Now I have to do the SUMX on top of that, right? Now I have to do the SUMX on top of that. So I'm going to do a SUMX. The X function is going to go to the first row in the table that was returned and get the total sales. And then it's going to go to the next row and the next row and the next row. So X functions really work in 2 separate distinct operations, if you will. The first part of an X function is it's going to iterate over every row of the table, and it's going to perform the X part. It's going to perform an expression. So for every row, it's going to return total sales for us. Once it's done, it's going to be a 1-column table. And then the second part of this 2 separate distinct operations here is going to be the sum. And the sum is going to say, oh, I see your 1-column table. I'm going to sum that up. Now you could do an average on top of it with AVERAGEX. You could do a min X, a max X. We could do a concatenate X. You've seen some videos of mine where I've done that. So we're going to do some X here, and I'm going to put a comma. And then I'm going to do a total sales, and I'm going to do that right there. So we're going to hit enter real quick, and we'll take a look at these results. Now I wish I would have just created this as a second measure so we could kind of compare it to the first one, because this should technically be, in some scenarios, this should generate maybe a higher number. So I'm going to do that. I'm going to call this V2. I'm going to call this V2. I should have done this from the beginning, so my apologies. And I'm going to do Control X. And I'm going to make this a little more stringent here. I'm going to go with 3,500. So we're going to go with 3,500. So only return the transaction numbers greater than 3,500. That looks great. Okay. So now I'm going to build one more measure super fast, and this will be the same thing, but it's going to be total sales greater than 3,000 V1. And then we're even going to do that. All right, and then I'll paste that in. I'll uncomment this code right here so we can see the difference. And I got to be careful because if they might look exactly the same just out of coincidence. They do not. Okay, good. So, oh, I got to change the number. I got to change the number. Remember, they're both 3,500, right? So let's change that to 3,500. And so in some situations, they're going to look almost identical just out of coincidence. And so we might have to change the numbers just a couple of times here to make this work. All right, so those work. I'm trying to think of, just thinking through the data, maybe we should go the other way. Let's do 2,000. Let's compare them. I should change the title of it to not be 3,000 anymore, but that's okay. Y'all know what I'm doing here, right? We're just kind of working through this together, talking about this scenario and how we would solve it. So if I go with 2,000 here, let's see here, are they all the same still? So they're all the same until we get down here. So this is where we start to see the difference. Up here, for the most part, until you get here, they're all the same all the way down. So we really can't tell the difference. It's just the way the data is set up. Maybe I should have went even further in the other direction. But what you see here is that the V2 version of this one right here, we're only going to return the rows where the total transaction is greater than 3,000, which means that is actually going to be a larger number, right? Because if I have a line item, think about what we're looking at here, 2,000. If I have a line item that's 1,900 and I have a line item that's 1900, I have two of them, both of them individually won't get added up in the other calculation, the original calculation that was looking at each individual row by the line item. It would look at the first 1900 and say, nope, you're out of here. It would look at the second 1900 and say, nope, you're out of here. But this one will count both of those rows as 3800 because they're part of the same transaction. And because they're part of the same transaction, it first aggregates them up before doing the filtering, right? So we're building this virtualized table here, this using summarize, using filter, and then using that X function on top of it to really get the results that we're looking for. Now, I wanted to dive a little bit deeper into this if you'll stick with me for just a moment, because we're going to make this more complex by talking about average. So I want to do this with an average real quick. I'm going to take the V1 out of this table. I'm going to rename this to average, right? And we'll go with greater than 3,000. And then for this first one here, actually we'll just stick with one, I think. We might want to do two, but we'll do two separate ones here just so you can see them side by side. I'm trying to think about the fastest way to get this video done and give you all the content here, but some videos are just going to be a little bit longer. So the way that you would normally say, hey, let's calculate or let's get the average that's greater than 3,000 is you would generally want to start like this, right? You would say calculate, I'm going to comment out all of this code real quick with control/. You'd say calculate the average of the internet sales amount, right? That's coming from the sales table where the internet sales amount is greater than 3,000. So we did that before. That's not new to us. We did it before. We just did the sum of internet sales before. Now we're doing the average of internet sales. And so I can run this calculation and we can put it here in the report, but again, it doesn't quite do exactly what we want it to do. So if I hit enter here, these numbers are going to go way down. They're going to be much smaller. Let's go up to the top here. And you'll notice that it's giving us some totals here where we're really going to see the difference. Again, it'll be in these later years, these later dates potentially, but it's giving us some averages that are around the 3,533 range, which is probably pretty close to what we're looking for here. But keep in mind that for later months and later years, we might have transactions that are above 3,000 when you add all the line items together, right? When people bought all their accessories. So this doesn't really account for that. And these numbers are probably a little bit off on a couple of them. So the way that we would fix this is instead of doing this right here, calculating the average, we can probably just modify what we already did here actually. So instead of doing a SUMX, remember, X functions are two separate distinct operations. The first part gets that one column table that has whatever the expression was that we performed on every row. Our expression on every row was, hey, go get the total sales, the sum of sales for that row. So go to the first sales order number, return the total sales. Go to the next sales order number, return the total sales. Go to the next, return the total sales. And at the end, when the X function gets done, we have a one column table. It's a table. The sum or the average or the min says, all right, I see your table. Now I'm going to perform this aggregation that you specify on top of that. And that's how we get the average. So if I change this right here to average, and I do average X, which is really what I was trying to get to in this video here, hopefully we're going to see some transactions. And I jumped right in full transparency to this video because I wanted to do it. So I don't remember if we're going to get something here or not, but hopefully we do. Hopefully some of those transactions are greater than 3,000. I think we saw that a moment ago. So I'm going to hit enter on this. We'll give it a moment and there we go. So we can see, oh, it's 2,000. Okay. I need to change this name here. It confused me for a minute. I was like, how's the average? All right, so this is awesome because now we're getting numbers down here I didn't expect. It threw me off a little bit. I was expecting to see 3,000. So we're seeing that for July of the third quarter of 2006, the average is actually 2,200. And so we can see how the average of our large orders, how their value has trended. Look at this. Tell me this isn't cool. How the average has actually trended down over time. Now the overall company is doing greater. We're doing better. We have more sales. We're not just living and dying on those big deals. we're selling a lot of little things and we're getting a lot of transactions that are above 2,000, but they're not as big as they might have been originally. Anyway, there's a lot in this video. I hope you watch it again and again. People keep asking me in the comments of my videos to do more DAX videos. And so I came across a scenario similar to this recently, and I wanted to cover it in this class because it covers a lot of key elements. It covers this idea and concept of having to build a virtual table first to, aggregate the data in some way. We did a group by there, and then we did a filter on it, and then we were able to do an X function on top of that, which is awesome. And once you get familiar with this pattern, and it is a pattern, once you get familiar with this pattern, you'll be able to solve a lot of complex scenarios yourself inside of Power BI. So that'll be awesome. Make sure you take a moment to hit that like and subscribe button. I hope you enjoyed this video, and we'll see you in the next one.